Good morning, students. In the previous video session, we have discussed about the measurement of length, and there we have learned how to find out the smallest distance by using screw gauge, vernier caliper, and how to find the largest distance by using triangulation method. Today we are going to see the another method, which is parallax method. Parallax method means it is another method to find out the largest distance. For example, suppose we want to measure the distance from our earth to moon. So the distance between the earth and moon is measured by using a parallax method. And here you can see the definition for parallax. Parallax is a name given to the apparent change in the position of an object with respect to the background when the object is seen from two different positions. Again, you can see that the definition of parallax, and you can take a screenshot of this. Parallax is the name given to the apparent change in the position of an object with respect to the background when the object is seen from two different positions. This definition, it is nothing. Suppose assume that I'll tell an example for parallax. You can see that you can close your one eye, just to close your left eye or right eye, any one eye you close it, and keep the finger. Take any of your finger, and just keep it like this in front of your eye by closing one eye. When you are closing one eye, when you are looking from left eye, you can see the finger is in one place, and you don't change the position of the finger. Hold it in the same place with the background. Maybe your wall is the background in your home. In front of your wall will be there. That wall is your background. So hold a finger in front of your eye by closing one eye, so that you can see that that finger is in one position. At the same thing, you don't move the finger, just close another eye and open which is closed previously. So now you can see that the finger position is changed with respect to the background. So this is observable. You can check it in your home. So again I am saying, just to close your one eye, keep finger in front of your eye with the background. Don't change the finger position. At the same finger position, same place, you can close another eye. So now what you can see is, when you are opening one finger, you can see that when you are closing one eye, you can see that the finger is in one place, and you can see that the finger is in another place when you close another eye. So this is what we can say that parallax. So parallax is a name given to the apparent change in the position of the object. That's what I am saying. You see apparent change. You can see a change in the finger with respect to the background when the object is seen from two different positions. That's what I am saying on just a simple example, left eye, right eye. You can try it in your home, so you can see the effect of parallax. Now by using this parallax, you can see how to find out the determination of distance of moon from earth. Here you see, by parallax method, finding the distance of moon from the earth. This is one of the important 3-mark question in this unit. You can mark and study how to determine the distance of moon from the earth. So that C is the center of the earth. I will show you the diagram. This is a diagram. You can see here. See, this is the center of the earth, and A and B are two diametrically opposite places on the surface of the earth. So from A and B, the parallaxes theta 1 and theta 2 respectively of moon M with respect to some distant star are determined with the help of an astronomical telescope. Then the total parallax, I will tell you what is this. You see, this is assume that this is on earth, this is earth, and center of the earth is C, and this is the position of the moon. Position of the moon. This is the position of the moon, and now what you can see is this is the point A. This is the point B. This is what diameter. So that is what A and B are the two diametrically opposite places on the surface of the earth. You see the diameter of the earth, and A and B are what two diametrically opposite places. So I said that this is the center of the earth. Assume that moon is here. When you are observing from the point A, you are assume that you are standing on the earth at the point A and you are observing the moon. Now you can see the moon is in this position. The same thing, suppose you are now shifting your position to another place on the earth. Now when you are observing, you can see that moon is in this place. That is what S1, S2, and this angle is theta 1 you can take, this angle is theta 2 you can take, and this you can take theta. So for this best example only I said just hold your finger in front of your eye with a background so that you can identify this thing. So assume that the moon position is here and you are standing on the point, standing on this point A on earth, and now you have seen that moon is here. Now you are shifting your position to the point B and you are observing this moon. You can see it is here. That is what the parallax, and here the parallax angle is measured. Theta 1 and theta 2 is measured. Now angle AMP is equal to theta. AMB is equal to what? Theta. Now how we can find out this theta? You know that this is a triangle. Three sides of this triangle is 180 degree, and this position is 90 degree. This position is 90 degree. So here you can write 90 minus theta 1, and this is 90 minus theta 2. Now, if you are finding this total angle, you see how you are getting this theta. That is what now I am showing. You will get theta is equal to theta 1 plus theta 2. I will show you how you will get this. You know this triangle, three angle if you are calculating, we will get 180 degree. And here, this is 90 minus theta 1. This angle is same 90 minus theta 2. Now, if you are taking this, what 9 theta plus 90 minus theta 1 plus 90 minus theta 2 is equal to 190 degree. 90 is theta plus 190 minus theta 1 minus theta 2. Now is equal to 190. Now plus 190, this 190 will go this side, so this will come theta minus theta 1 minus theta 2 is equal to 190 minus 190. Now we know that 180 minus 190 is 0. So theta minus theta 1 minus theta 2 is equal to 0. Now you need to find out the theta, so that you can write theta is equal to theta 1 plus theta 2. Which is what? This is how we are getting this theta value. Theta 1 plus theta 2 is equal to theta. Now you can take this theta is equal to what? Theta is equal to AB by MC. AB by MC. So that is what now I am going to write here. Not clear. Okay. So you can see here theta is equal to AB by what MC. So MC is equal to AB by theta, you can write. So MC means it is the distance of the moon from the earth. So that we will get the distance from the earth of moon. So this is what a parallax method, and this is one of the important 3-mark question, determination of distance of moon from the earth. You can take it screenshot of this part and study, and this is just for how you got this theta value. So you can take a screenshot and study. It is one of the 3-mark, very important, repeatedly asking 3-mark question in this unit. Now the next thing is radar method. So already we have learned measuring shorter distance, screw gauge, vernier caliper, measuring larger distance. One is triangulation method, another one is parallax method, another one is radar method. Last one is radar. You know this thing, this radar. Now we know that we are living in a digital world, technology world. So you can see a picture here. You see on a transmitter. You can see this is a transmitter, and this is a aeroplane. No. So you know that now by using this radar system, the flight position and all finding. So not only the flight position, planet position, and how much distance it is far from the earth and all finding by using this radar method. Now This is what radar means. Word radar stands for radio detection and ranging. This is also another important question. Radar stands for radio detection and ranging. Now, what is the use of this radar? Radar can be used to measure accurately the distance of a nearby planet such as Mars. And in this method, radio waves, how it is used? First thing, what is its full form? Radio detection and ranging. What is its use? So to detect the to detect the distance of a nearby planet such as Mars and all, and you can detect the flight position and all by using this. And how it is used, it is very important. You can see a transmitter here. So you can see a transmitter here. From this transmitter, radio waves are sending. So the radio waves are sending. When it reaches nearby the flight, it is getting reflected back. It is getting reflected back. Then it is, so they are measuring the time. How much time taken for these radio waves to transmit from this transmitter to this flight, then coming back to this transmitter. So the total time is measuring for these radio waves to transmit from this transmitter to this aeroplane. That is what here you can see in this diagram. So that is how it is used. So in this method, what radio waves are sent from transmitter, then after reflection from the planet are detected by the receiver. So you can see in this diagram, radio waves are sending and it is reflected from this flight, then it is coming back to the receiver. Now, how? By they are measuring the time interval, how much time taken for these radio waves to move from this transmitter to here, and again it is coming back to the receiver. So the total time is calculated. Then they are using the formula. We know that the basic formula, speed is equal to distance traveled by time taken. By using this formula, so you know that they are finding, this radar method is finding that is to find the distance. So radar method is used to find the distance. So from this formula, distance is equal to speed into time. So by using this formula, speed, they know the speed of this radio waves. Radio waves means it is an electromagnetic waves. So it will move with the same speed of light, 3 into 10 to the power 8 meter per second. So that easily they can find. If they are calculating the time value, they can substitute in this formula and divided by 2. D is equal to speed V into T by 2. Why by 2? Why divided by 2? Why divided by 2? Because here they are measuring the time taken from transmitter to flight. Again it is to the receiver. So that is what here they are using divided by 2. So again, what is radar stands for? What is radar stands for? Radio detection and ranging. What is the use of it? To measure the distance of a nearby planet such as Mars and all. And how it is used? Yeah, it is sent from the transmitter and it is reflected from what? Planet, and measuring the time interval for these radio waves send and receiving. So the total time is measuring, and by using the formula, basic formula, speed is equal to distance traveled by time taken. Then from this, that only d is equal to finding the distance. D is equal to v into t by 2. Okay, so v means what? Speed of the radio wave. T means time taken. Okay, so this is what. So from this part, from this last video and this video, we have discussed how to find out the length, shorter length and all, shorter distance by using screw gauge and vernier caliper. And today's video, parallax method. So parallax method, triangulation method, radar method, screw gauge, vernier caliper. From these 1 3-mark question you can expect. So all of you watch this video. It is very important. Okay, so that now next you can see is some of the measured distance. So range and order of length, you see, this is a distance which is measured by using astronomical telescope and all, by using this radar method. So you know that astronomical telescope which is used by the astronauts. Okay, so you can see, you can take a screenshot and just go through this table. So you can see all the sizes, distance to the boundary of observable universe 10 to the power 26, distance to the Andromeda galaxy, size of our galaxy, distance from the Earth to nearest star. So every distance is measured and given for you. So go through this part and here some of the unit is given. Okay, unit and its value is given. This is Fermi. Fermi is the smallest unit we are using to measuring length. 1 Fermi means, you see the size, 10 to the power minus 15 meter. Very small. Very small means 0.15. 0. 10 to the power minus 15 means what? 10 to the power minus 15 means 0. How many 0? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, then 1. This much small. That is what 1 Fermi means. Next one is 1 angstrom, 10 to the power minus 10 meter. This is angstrom symbol. Then this is Fermi. Then 1 nanometer means, you can see the symbol 1 nm, 10 to the power minus 9 meter. Then 1 micron. 1 micron or 1 micrometer, mu. This symbol is known as mu. You have to know this symbol, how to write. It is very important. This symbol name is mu. Micrometer. Nanometer means nm. This is mu. MEW. Mu. Mu. Okay, mu symbol. MEW. So mu, this symbol you can pronounce. Then 1 light year distance it is given. Distance traveled by the light in vacuum in 1 year. Then astronomical unit is given, 1 parsec. Distance at which an arc of length. So this unit and all you have to go through. Then from the mass also you can see some on table, this values and all, just to go through that. Okay, take a screenshot and just to go through. Electron mass, proton mass, uranium atom mass, red blood corpuscles mass, RBC. Then cell mass, dust particle, raindrop, mosquito, grape, frog, all mass is given here. Okay, just to go through this. Okay. Okay, so my dear students, go through these today's videos and study the important question what I told. Surely you will get on 3 mark question from this part, today's videos and previous videos. Surely you will get on 3 mark question. So go through that, study well, prepare well, take online classes very seriously. Thank you all. Bye bye.